Hello everyone. We will solve another one numerical problem based on Poisson's equation. The question asks you to find potential and volume charge density at the point P, and the medium is given as free space. Potential field V is given, which is 6 rho phi z volts. Now, you should look at the point P and the coordinates of point P. It is 0.5, 1.51. The coordinates of point P are given in rectangular system. The point P coordinates says 0.5, 1.51, which is in rectangular system. But the potential function V is given in cylindrical system. So what we are supposed to do is we have to convert this point coordinates to cylindrical system and then substitute the corresponding value of rho phi z. So from this values of x, y, z, we have to find rho phi z. We have already discussed how to find the values of rho phi z from x, y, z. That is, rho can be found as under root x square plus y square. Phi is tan inverse y by x and z is z. So when you find the angle phi, depending on the signs of x and y, we can find the value of phi. Here, both x and y are positive. So we can consider this angle phi to be in the first quadrant. So let us try to find the values. So if you substitute x value as 0.5 and y value as 1.5 square, you can compute using the calculator. You'll be getting the value of rho as 1.58. And for angle phi, if you are finding tan inverse, y is 1.5, x is 0.5, you can get the answer in degrees or radians. In degrees, it is 71.56. And in radian, this angle phi can be written as 1.249 radians. If you use your calculator in degree mode, you'll get the answer in degrees. If you're using the calculator in radian mode, you'll get the answer in radian. And z value is same. So these are the values of rho, phi, and z corresponding to the given point, which is in rectangular system. We have converted to cylindrical system. Now, what is the requirement of representing the angle in radians? So when we look at the function of potential given, here 6 rho phi z. So whenever you have rho given without the trigonometric function, if you are multiplying the phi value directly with any constant, this angle phi must be taken in radians. You cannot take degree value here and put in this multiplication factor. When you are taking the multiplication factor directly, the angle phi, this has to be in radians. For that purpose only, we need the angle phi in radians. So here you should substitute 6 multiplied with rho value, which is 1.58, multiplied with phi in radians, 1.249, multiplied with z, 1, to get the function v at the corresponding point. So let us try to evaluate that. So v at point P can be estimated as 6 rho phi z, which is to be written as 6 into 1.58 into 1.249 into 1. So this is going to give the answer for V as 11.84 volts. You'll be getting the answer as 11.84 volts. You can use the calculator and compute and check whether you're getting this answer. Next, we need to find volume charge density. So for finding volume charge density, that is the second subdivision. This is the first subdivision. For the second subdivision, you need to find volume charge density. We have to use the Poisson's equation formula. I'll be rewriting the Poisson's equation for your understanding. Del square V is minus rho V by epsilon. From this, you can write rho V as minus epsilon into del square V. Since in the question it is mentioned as free space, I can write minus epsilon naught into del square V. And we need to write what is del square V in cylindrical system. In cylindrical system, del square V is 1 by rho, dou by dou rho of rho, dou V by dou rho, plus 1 by rho square. Second order differentiation, I should write. So instead of writing second order differentiation, I will write dou by dou phi of dou by dou phi of P. Then again, second order differentiation for z, I'm writing 2 times. Dou by dou z of dou by dou z of V. Now, this V should be written as 6 rho phi z. We will apply this and find what is del square V. Or we can write directly in the formula for rho V, which is minus epsilon naught into this del square V, which is 1 by rho dou by dou rho of rho multiplied with dou by dou rho of 6 rho phi z. So this is the first term, and for the second term, 1 by rho square dou by dou phi of the 6 rho phi z. Then dou by dou z of this V, which is 6 rho phi z. Now we can continue that. Rho V is minus epsilon naught into 1 by rho dou by dou rho of rho multiplied with, we have to differentiate this with respect to rho, which is going to give 6 phi z. And we can write for this differentiation, this is going to be 6 rho z, and this differentiation is going to be 6 rho phi. So we will write the remaining terms accordingly. Plus 1 by rho square dou by dou phi of this plus dou by dou z of this. Now when you look at this differentiation, next time we have to perform the differentiation. Here there is no phi term, this differentiation is becoming 0. Here there is no z term, this differentiation is becoming 0. And differentiation of this term only will be left. So I can write this as 1 by rho into 6 phi z multiplied with minus epsilon naught. This is the rho v. You can write the formula, the expression with the unit coulomb per meter cube. Now what we are supposed to do is we have to substitute the value of rho phi z at this point to get rho v. So rho value, phi value and z value, we should substitute. Rho value as 1.58. Phi value should be taken in radians because this is the value which should be given in the multiplication factor directly, and z is 1. Taking these values into this expression of rho v, we will get the final answer to be minus 42.028 picocoulomb per meter cube. You already know pico is 10 power minus 12. So epsilon naught value should be substituted. You know epsilon naught for free space is 8.854 into 10 power minus 12 farad per meter. I hope you understood this problem. Thanks for watching the video.